Good morning. Welcome to our first online lesson. Everyone hopefully watched the video here with the soap and milk repelling and making beautiful colors. Well, why do soap and milk repel? It has to do with something called polar and nonpolar bonds. So in this video, we are going to learn about polar and nonpolar bonds. First, let's review covalent bonds. In covalent bonds, atoms share electrons. Why do atoms share electrons? Atoms share electrons so that they can get 8 electrons, or 2 electrons in the case of hydrogen. Now, let's look at these pictures. Both these pictures represent covalent bonds, but there are two types of covalent bonds. In the first picture, Emily and Sarah are both cold, so they share the blanket. Do they share the blanket equally or unequally? They share the blanket equally. This represents a nonpolar bond. In the second picture, Emily and Sarah are both cold, but Sarah is extremely cold. So do they share the blanket equally or unequally? They share it unequally. Sarah gets more of the blanket. This represents a polar bond. Why do we call these polar and nonpolar? Well, think about the Earth. The Earth has 2 poles. What are the names of these 2 poles? The North Pole and the South Pole. So the Earth is polar because it has 2 different sides, the North Pole and the South Pole. Let's look at these pictures of atoms. In the first picture, the atoms share electrons equally, and both sides are the same. Is this bond polar or nonpolar? This is a nonpolar bond because both sides are the same. In this second picture, atoms share electrons unequally. So the 2 sides are different, like the North Pole and South Pole of the Earth. So is this a polar bond or a nonpolar bond? This is a polar bond because the 2 sides are different, just like the North Pole and the South Pole of the Earth. So, to summarize, when atoms share electrons equally and the 2 sides are the same, it's a nonpolar bond. But when atoms share electrons unequally and the 2 sides are different, it's a polar bond. Well, why are some bonds polar and other bonds nonpolar? Why do sometimes atoms share electrons equally and sometimes they share electrons unequally? It has to do with electronegativity. Electronegativity is how much an atom attracts electrons. So you see here, this electron is attracting, this atom is attracting these electrons here. So an atom with a high electronegativity has a strong attraction for electrons. An atom with a low electronegativity has a weak attraction for electrons. Well, we are going to use this chart because this chart shows us all the electronegativities of all the atoms. Can you look at this chart and find the atom with the highest electronegativity? The atom with the highest electronegativity is F, fluorine, with 4.0. That's the highest electronegativity. And because it has a high electronegativity, that means that fluorine has a strong attraction for electrons. Well, we are going to use this table of electronegativities to determine, is a bond polar or nonpolar? And here are the steps that we're going to follow. Okay, let's do it with carbon and oxygen first. This is a bond, a covalent bond between carbon and oxygen. First, we have to find the two atoms on the table of electronegativities. All right, well, here's carbon, 2.5. Here's oxygen, 3.5. If the atoms have the same electronegativity, well, do they have the same electronegativity? No, they don't. It's different. So we can skip step 2. Okay, if the atoms have a different electronegativity, then they share electrons unequally. Because carbon has a higher electronegativity, it's going to pull electrons more strongly towards this side. Therefore, this bond is polar. We're going to have a negative side over here with the electrons and a positive side over here where there's less electrons. There's two different sides, like the North Pole and South Pole. So this bond is polar, and we can label it polar. And we're going to draw an arrow towards the more electronegative atom. So which one is more electronegative, carbon or oxygen? Oxygen. So we're going to draw an arrow towards oxygen. Okay? And the last step says that there's one exception. A bond between C and H is always nonpolar. Do not draw an arrow. Well, this bond is not between C and H. Okay, let's look at the second example with O and O. Okay, first we're going to find the two atoms on the table of electronegativities. Well, in this case, both atoms are the same. They're both oxygen. So that means that oxygen is 3.5. So this oxygen has a value of 3.5. This one also is the same value of 3.5. So these two atoms have the same electronegativity. That means that they share electrons equally. They don't get pulled more to one side or the other. The two sides are the same. Therefore, this bond is nonpolar. And if the bond is nonpolar, do not draw an arrow. So we do not draw an arrow there. Okay? And then again, the one exception is a bond with C and H is always nonpolar, but this isn't C and H, okay? All right, let's look at the next example, C and H. Okay, well, we could do these first 3 steps, but remember, this is our exception. A bond with C and H is always nonpolar. So we do not draw an arrow. We just say nonpolar, and we are done. Okay, so that is how to determine if a bond is polar or nonpolar. Watch this video again if you need to. You can watch it as many times as you want, and then do the practice and the assessment for identifying if a bond is polar or nonpolar. All right, thanks for listening.